Okay, so for this question, they give us a information about a star. That's a Theta 1. Orionis is a main sequence star. The following data for Theta 1 Orionis are available. They give us the luminosity of the star compared to that of the sun. Here, this is like the symbol for the sun, just a circle with a dot inside of the sun. Then they also give us the radius of the star compared to the sun, the size of the star, like 13 times the radius of the sun. And the apparent brightness, like how we can perceive it from the Earth, which is much less compared to the brightness of the sun, the apparent brightness. And then they ask us to find the surface temperature of the sun is like they ask us to estimate the surface temperature of the star, and they also provide more information about the surface temperature of the sun, which is about 6,000 Kelvin. So where should we start? We should use the formula from the data booklets, right? So if you look at these, we can find like surface temperature. Okay, it related to some T, right? The big T, which measure in Kelvin, and we can see, oh, and we are also given the luminosity, the L. So in those questions, this is the questions that we can use, right? This one, which is luminosity equals to a constant, which is a Stephen Boltzmann constant. This is the value of it, times with the area surface of the star and the temperature surface of it to the fourth power. You see that with this constant, the unit should be watt over times with meter to the -2 and Kelvin to the -4. Then they can cancel out with those units here. And luminosity basically is just a power. Each unit is watt. Okay, so actually, like if we use this equation, we can see that to solve for the surface temperature, right? Then we should get the fourth root of this ratio. Like we just move this one to the other side, and then we take the fourth root of it. But do we know the luminosity of the star? Yes, we know. Do we know the area? Not really, right? But we know that area of the sphere, the surface area, okay? This is the surface area. Surface area of a sphere should be 4 pi times with the radius square. So if we know this, we can find this one. But we don't really do have them in numbers, but we just know that this is how much of them compared to the all of those quantities of the sun. So it means that we need some ratio here. So basically, we also can apply the same thing for the sun, and we got this expression. To find the ratio, just make a ratio. So you can either have the sun above and the star below. Here, I just have the star above and the sun below. It doesn't matter, as long as you have the other expression to be like in respective with that. So if this is a star, this should be the star. It should be the star. It's the sun, sun, sun. So then we can see that the sigma, the constant here, just the same. We can cancel them. And then what left here, because we want to solve for the temperature, then I just move this one to the other side. So I need to like multiply both sides with it and can cancel out. So this one should be the above, and then the area of the star should be the below. So then we got this one. And then again, we don't have the area of the surface, but we know it's related to the radius. So then we just have here, this is the radius of the sun, and this is the radius of the star. And we have to have square of them. So basically from this, we got this equation. So if we know this one, we know the ratio between these two, we know the ratio between these two, we know the temperature of the sun, right? Then we can solve for this one, right? So basically just rearrange to solve for the star. Then this one should be the fourth power, right? The fourth power of this expression. We have this one multiplied with this ratio, right? And then we just take the fourth root of it, and then just plug in the values. Here we have from the problem statement, the radius of the star is like 13 times of the sun. That's why the ratio of the radius of the sun above the star should be just 1/13th, right? And then we square it here. And then for this one, the luminosity of the star is much larger than the sun. Then that should be 4 times with 10 to the fifth. And then just using the calculator, you can find this temperature around these values. And I would just pick, we just need two significant figure. So that should be around 42,000 Kelvin. Okay, so that answer for this question. I would say that whenever you got some problem like that, just make sure that you have the ratio that could be useful for you, especially when they give you the information like the luminosity of the star compared to that of the sun. Make sense, right? Yeah, please let me know if you have any questions. Thank you. Good luck.